Hello students, welcome to lecture 7 of our PCS Booster course. Topic for today's discussion is from General Science section. There was a report regarding increase in water body pollution due to excessive use of detergents. So in this particular topic, as we know in PCS General Science section, there is a specific topic which is mentioned as action of soaps and detergent. So typically on every alternate PCS exam, there is at least one question which revolves around this chemistry section of soaps. Sometimes they ask about the hard and soft water difference. Sometimes what are the methods by which this temporary or permanent hardness is removed. At times the question can revolve around how soaps are prepared, and the most basic part is how soaps act, and there is a comparative difference between soaps and detergents. So in just in case you have not yet prepared this chemistry part, so this lecture is meant for you. If you have attended our class lecture, more or less this is a revision part which will more or less add one or two new dimensions to the topic. So without wasting any time, let's first of all decode what exactly are soaps. So as you could see on your screen, sodium or potassium salts or fatty acids derived from vegetable oils or animal fats. The formula part is just for your reference purpose. Otherwise, there is no need to mug up the chemistry or the reaction part. So basically, we can say soaps are prepared by a chemical reaction where fats or oils are reacted with a strong base, typically caustic soda, sodium hydroxide or potassium hydroxide are the most commonly used, you could say, bases in this particular reaction. So this reaction is technically called as saponification. So make sure you are clear about what is transesterification, what is hydrogenation, what is the saponification process. So whenever a single word is asked, the how soaps are prepared, your answer should be saponification. Now key point to mug up in this fact is the sodium potassium salts. So make sure you don't get confused with the washing soda or the baking soda or some other chemistry related themes, because at times the general science part is ignored and we tend to confuse multiple products which we have covered in examination stage. Coming to detergents, in detergents there is no biomolecule directly involved because fats or oils represented the basically the lipid or the, you could say, the fatty acid chain. But in case of detergents, it's totally a synthetic chemical material which is predominantly dominated by chemistry name. So basically in definition you could see it is referred as synthetic. The key word here is synthetic cleaning agents made mainly from petrochemicals. So basically the chemistry part is the important one, with added components like surfactant, bleaches and fragrances to enhance, you could say, product value. So more or less when we are relying for washing our new, or you could say the main clothes, currently detergent has been the norm, and more or less detergents have a better cleaning action than soap, so they are preferred on, you could say, okay, on any given day over the soaps. More or less soaps also hold significance, and when we will compare their differences you will come across that some points actually are still in favor of soaps as well. Now let's dwell little more into the chemistry part of the soaps and detergents, because if they're asking a superficial question then they will just ask that what exactly is the biochemistry part of soap. So on that purpose only the sodium potassium word was more than enough. But if they dwell little deeper, what are the exact ingredients? So this slide is going to help you. For soaps, the vegetable oil or fat is the primary raw material, typically coconut, palm, olive, soybean. So these are some of the ingredients which are majority of the times employed for soap making industry, and soap can be prepared at home as well, because since the reaction is not too much of a chemical reaction, because they were just it was a chemical reaction in which these fats and oils were being reacted with caustic soda, just I have like sodium hydroxide, or caustic potash, which is potassium hydroxide. In that particular reaction the fat splits into fatty acid and you could say glycerol, because lipids are esters, and then the combined product is referred as the soap one. Initially, since we are using for bathing soaps as well, so typically the soaps which are used for, you could say, daily consumption, a fragrance is added, but typically perfumes, so sandalwood oil, synthetic scents, and specifically to make them little more attractive, colors are added as well, and the fillers like talc, sodium silicate are also additional themes. If they are specifically relying on some soap which is promoting itself that it is used for cleaning of wounds, or you could say for antibacterial worms, because at times people are oversensitive about our environment and they like to serve the antibacterial fungal part as well. So in that case, in natural products, neem oil is one of the dominant product. In chemistry, triclosan is often associated with these properties as well. So basically, we can say in action of soap, or you could say soap preparation, or what exactly are soap. If you have covered this much, more or less the basic attemptable questions are likely to be in your hold. In case of detergent, theme more or less is tilted towards the chemistry part. As you could see, the name of surfactant itself is a technical one, alkyl benzene sulfonates, because even in class lecture we have said detergents are alkyl benzene sulfonate products. So basically sulfonates are the chemistry products, or the sodium lauryl sulfate. So basically majority of detergents use this chemical as a surfactant, and to build enzymes, so this sodium carbonate is nothing but the washing soda. So this also finds mention, and the phosphate part which we were referring from current perspective, because overuse of detergents and when the proper water treatments are not available, this froth which you see on your local water bodies is one of the reasons for that is the phosphate itself, because the nutrients like nitrates and phosphates, when they enter our food chain, they cause eutrophication. So that would be the controversial part associated with detergents. Apart from that, the bleaching dyes, perfumes are also used, because modern times every product wants to be visually as well as appealing from odor point of view. So basically they also experiment with multiple chemicals. So in the initial two slides we have just built the chemistry part, what exactly are the ingredients in the soap and detergent, what are the chemical reaction associated. Now let's delve to the another dimension of this theme. How do soaps act? So typically you have to understand, when these soaps were prepared by saponification, it was not some random reaction, it was intentional, you could say, preparation, in which we tried to join two specific themes, the sodium potassium part which will represent the ionic part of the soap, and apart from that long fatty acid chain. Now, when these two are combined in a soap, a tadpole-like structure is formed. As if you focus a little bit more, so you will see the head part is the ionic part, which may be sodium or potassium, and this long chain is representing the fatty acid chain. Now, why this chain is necessary? Because typically when there is a stain, some butter or any fat product has fallen to your shirt, incidentally I am also wearing the white one, you will see there is a particular spot will appear. So had it been some product which was, you could say, polar in nature, it would have been easily removed by strong action of water. But typically in case of fats, there is a problem. The fats being, you could say, non-polar in nature, they do not get dissolved in water. So repeated action of water on that particular stain is not going to bring the desired results which we are anticipating. So basically here, when we rub the, you could say, soap over that particular stain multiple times along with water, then the particular reactions comes into the picture. So in this picture you will see that there is the dirt particle, oil or grease, which is has strong non-polar characteristics. So typically when we are, you could say, washing with the soap, the fatty acid part is mainly you could say hydrophobic in nature. Hydrophobic in simple terms means water repelling. The opposite term, the ionic part, sodium ion or potassium ion, would be hydrophilic or water attracting. So now this particular part, which is water repelling, is attracted to the fatty part and it forms a mislis, along with the ionic part tends to attach itself to the polar or water part. So while will multiple scrubbing actions, this mislis gets automatically removed and the dirt, the stain is no longer visible. So more or less you just need to understand that there is an ionic part which is polar in nature and there is a long hydrophobic chain which mainly the job is to attach itself to the dirt and make a mislis which is water, you could say, soluble, and eventually the whole part develops around this chemical reaction. So soaps are, when used with the soft water, are quite efficient in removing such different kinds of stain, and we use them quite occasionally as well. So make sure an examiner might confuse you with some other word, or they might tend to interchange the chemistry nature of these structures. So make sure you are clear that sodium and potassium, since they are ion are something which lose electron to gain a positive configuration. So in case of this, the Na positive is reflecting in your screen. Now coming to the next dimension which we have to cover in this given topic is that both are used for cleaning action, both more or less have tilt towards chemistry and action is more or less related. So what exactly are the differences? What makes soaps different from detergent? So each and every single difference highlighted in the screen can be asked in examination if examiner chooses this particular theme to test students. So first difference is the definition part. Once again we are re-emphasizing soaps are sodium or potassium salts of long chain of fatty acids. In this particular slide they have used the word carboxylic acid. Detergents are sulfonate or ammonium salts of long chain of carboxylates. So basically their chemical chain is more complex than the you could say soaps, and it does not carry the fat or oil part, which is a biodegradable, or you could say part. So second difference is once again re-emphasizing which I have highlighted. So soaps carry an advantage that they are not too harmful for nature, because since they are prepared from fat and oil, microorganisms can easily decompose them. So basically they are biodegradable in nature, eco-friendly. Whereas detergents, since they are made of complex chain of sulfonates, microorganisms would not be in position to degrade them. So basically they are non-degradable. So that's why in current affair that report highlighting that water bodies are carrying lot of phosphate, eutrophication is going on in some water bodies, was in news. Now the third part is once again important part. Soaps normally work when the water is soft. It does not carry too high mineral content. So that's what highlighted. Soaps do not clean well in hard, acidic and saline water. So you have to be careful that only the fresh water and typically the soft one is preferable when you are using a soap. Whereas detergents are effective not only in soft water, they are equally effective in hard water, saline as well as acidic water as well. So flexibility in action makes detergents a preferred choice over soaps. Then this point is linked to the previous point as well. So when you are using or using soaps with the hard water, it will not produce the efficient mislis formation or the cleaning action. Instead it will form a scum, a yellowish, you could say, discoloration type, scar type would be visible. Whereas in detergents they form lather with hard water. So lather is nothing but the jhag which we call in local language. So cleaning action is quite dependent upon that the froth action as well. So basically in the next part difference they have highlighted that they are made mainly from natural sources, since the vegetable or animal fat or oil is going to be used. Whereas in case of detergents, they are synthetically derived from specific chemicals. So that's what makes them, you could say, origin, or you could say chemical difference. Then the soaps are not ionic in nature, whereas detergents, if you dwell a little more deeper, you will see another set of classification where they are classified as cationic, anionic, or non-ionic in nature. Cation and anion are nothing but the ionic forms. If a particular compound loses electron, you would say it retains positive charge, it is referred as cation. Conversely, when it gains electron, it requires negative charge, it is called anionic in nature. So once again, the next difference is the repetitive part only, just for the sake of difference you could see them in. They have said they are not effective in hard and saline water, whereas they do not lose their effectiveness detergents in these scenarios. And finally, there is a example part. Sodium stearate can be a typical example of a common soap, whereas in detergent, sodium lauryl sulfate is anything related to long chains of sulfonates or sulfates are the detergents, anionic or cationic. So make sure this difference part is clear for you, because this is one of the part in which a question can easily be framed. So you can say almost detergents have advantages in majority of points. Only in case of environment friendly nature, their difference arises. Apart from that, a final difference could be that soaps are economical in nature, whereas detergents are comparatively costly. So economic difference is also what makes them products influences the product preference. And one associated topic which you can ideally cover while preparing this soap and detergent part is the hard and soft water difference, because we have seen the hardness of water is prevalent in northern belts. So you should be clear as an administrator what exactly is the problem of hard water. So the basic differences of hard and soft water are highlighted, and make sure you do not tend to confuse hard water with heavy water. Heavy water is altogether a separate theme which we use in nuclear reactors while dealing with the components. So basically there the deuterium oxide or the D2O is referred as the heavy water. Now in hard and soft water, as you could see on your screen, the first major difference is that hard water is rich in minerals like calcium, magnesium, salts, it could be chloride and sulfates as well, whereas soft water typically contains less minerals. So that's the first difference on which this term is used. Now coming to mineral concentration, as you could see, the baseline is 60 milligram per liter. So this is the quantitative value, even though it has not been asked in any exam as of now. Now behavior of with the soaps, we see that in you are using a soap with the hard water, it will form a curd like structure, there will be no lather. Whereas in case of soft water, there will be a good lather. So for washing dishes, hard water is not one of the preferred choices. It will be difficult to clean. It will be a lot of effort would be entailed. Whereas in soft water, soap will produce the immediate result. And with the hair and skin, we have seen that particularly hard water makes them dry, whereas in case of soft water there is no such effect. So at times we have seen lot of people complaining that they are losing hair, they are not using they are losing the texture of their original hair once they migrate to some specific location. So there you have to understand, typically the hard water at times makes them the dry, so it's not suitable for everyone. And once again, the boiler part, we have seen soft water is ideally preferred, whereas in case of a geyser or you're using some object which is using hard water, it is unsuitable. More or less, it will accumulate the salts and it will decrease the shelf life of product. It will require repeated maintenance. So basically, we can say even though there is nothing problematic related to drinking or health part, because since it's rich in minerals, but for daily usage, typically the cleaning action and some electronic products might get affected with the hard water. And finally, should be clear if you are dealing with temporary or permanent hardness, what could be your strategy. So in temporary hardness is not difficult to deal with. You could just add few drops of lime, or just the boiling of water would help in settling that calcium salts at the bottom, and water can be filtered and used for consumption. Whereas permanent hardness is little complicated. You will require the use of washing soda, the sodium carbonate, and also the distillation method can be employed, but that's more of a chemistry, it's not too practical for household use. So make sure you are clear about the composition of caustic soda, washing soda and baking soda, because in chemistry question repeatedly are asked from this section.
And now we have once again highlighted what exactly is the problem related to hardness of water. So if any question which you feel remains unaddressed regarding the soap and detergent action or their composition, or you feel the basic differences, feel free to ask them in comment section. We will get back to your genuine queries. So I hope this series is adding at least a revision part, or helps you in updating few topics which you might be taking granted, or it at least is building one or two new facts to your original preparation. So we'll be back with another value addition lecture, which would be lecture number 8. So stay connected with Civil Service Gurukul PCS Booster Course. So thank you very much. Have a nice day.